Technology can treat water, but certification makes it drinkable. For direct potable reuse at home, the most important question is not, does the system work? It is the system verified to protect human health every second it operates? Because safe drinking water is not only an engineering achievement, it is a public health commitment. In conventional systems, performance is measured during installation. In potable reuse, performance must be proven continuously. Certification is based on defined treatment targets, validated removal performance, and continuous monitoring. The system must demonstrate that it meets safety requirements at all times, not only under ideal conditions. Health protection is defined through treatment targets. These targets represent the required reduction of viruses, bacteria, and protozoa. They are calculated based on acceptable risk levels, not on aesthetics, not on clarity. This transforms water treatment into a quantifiable public health barrier. But pathogens are only half the story. The other critical challenge is chemical contaminants. Pharmaceuticals, pesticides, and industrial compounds can persist in wastewater. A certified system must also prove its capability to remove these invisible threats. This requires advanced processes like reverse osmosis and activated carbon, each validated to reduce specific chemical families to levels far below health advisory limits. Validation monitoring does not measure contaminants directly. It measures whether each treatment barrier is performing correctly. For example, membrane integrity testing confirms physical removal. UV sensors verify delivered disinfection dose. Oxidation systems confirm reaction efficiency. If performance drops below the validated threshold, potable delivery stops automatically. This is called fail-safe operation. In certified potable reuse systems, safety is automatic. If power is lost, a sensor fails, or a barrier underperforms, the system switches to protection mode. Water is no longer delivered for drinking. This ensures that users are never exposed to untreated water, even during system failure. Modern certification is not based only on physical inspection. It is digital. Performance data is recorded and stored. Authorities, service providers, or building managers can verify operational history, maintenance records, and safety events. Compliance becomes transparent and traceable. With this level of data collection comes a responsibility to protect it. The digital backbone of a certified system must be secure. Data encryption, secure cloud architecture, and protection against unauthorized access are not optional features. They are integral to the system's safety promise. The integrity of the water depends on the integrity of its data. In potable reuse, maintenance is not a technical detail. It is a health protection measure. The system knows when a component reaches the end of its validated life. It does not allow operation beyond that point. This prevents silent performance decline. Safety is enforced by design. Certification creates trust. Without it, potable reuse remains With it, decentralized drinking water becomes a reliable infrastructure. People do not need to understand the treatment process. They need to see that it is verified, monitored, and protected by fail-safe logic. Trust is the final barrier in the multi-barrier system. Safe water is not only treated, it is continuously proven safe.